Welcome to The Explainer. Today, we are diving into the incredible story of Java. And believe me, it's a wild one. This is a language that, believe it or not, was born from a project to control things like microwave ovens, and it ended up completely revolutionizing the internet and changing the art of programming forever. All right, so here's our game plan. We're going to start with the big question. Why do we even need new languages? Then we'll trace Java's family tree. After that, we'll get into the accidental pivot that changed everything, uncover the magic behind its core tech, track its constant evolution, and finally, really dig into its lasting legacy. So, first things first. To really get why Java was such a big deal, we have to back up a little and ask a really basic question. Why do programmers keep inventing new languages anyway? Aren't the old ones good enough? Well, it really boils down to two big things. First, the world changes. New technologies pop up, like the internet, and we need new tools to build for them. And second, it's about getting better at the craft itself, just finding smarter, safer, and more powerful ways to tell computers what to do. See, in the early days, creating a language was this constant tug of war. You had to make choices. You could have a language like BASIC, which was super easy to learn, but honestly pretty weak. Or you could go with something like assembly language, which was incredibly fast and efficient, but it was also incredibly difficult and, frankly, dangerous. One little mistake could crash the whole system. There just wasn't a tool that gave you the best of both worlds. Okay, so keeping that constant drive for better tools in mind, let's look at where Java came from. It didn't just appear out of thin air. It really stands on the shoulders of giants, inheriting its DNA from two hugely important languages that came before it. First up, in the 1970s, you have C. C was a game changer because it brought order to chaos. It introduced structured programming, which helped fix the tangled mess that programmers called spaghetti code. Then, as software started getting massive, C++ arrived in '79 to solve the next big problem, just sheer, overwhelming complexity. And it did this using a powerful new idea called object-oriented programming. Basically, it was a whole new way to think about building software. And this OOP thing was a huge deal. The best way to think about it is like building with advanced Legos instead of just a pile of raw clay. You organize your code into these logical objects that bundle together data and the things you can do with that data. It finally gave developers the tools they needed to build enormous, complex applications without everything falling apart. So by the early '90s, C++ and its object-oriented approach were on top of the world. It really felt like the ultimate language had been found. But another revolution was brewing, and it was about to come from a project that nobody saw coming. So, get this. In 1991, a team at Sun Microsystems led by James Gosling kicked off a new project. At first, they called it Oak, and their goal had nothing to do with building some big general-purpose language. Nope, they were focused on a super specific, kind of niche problem in the world of consumer electronics. Here was the issue. Every little gadget, whether it was a remote control or a TV set-top box, had its own unique little brain, its own CPU. And that meant if you wrote software, you had to rewrite and recompile it for every single different chip. It was a total nightmare, incredibly expensive and just painfully slow. They knew there had to be a better way. And this is where the story takes a legendary turn. Just as this team is hammering away at their problem, the World Wide Web explodes onto the public scene. And what was the web, really? It was a giant global network of millions of different computers, with different CPUs and different operating systems, all needing to run the same stuff. It was their exact problem, but magnified a million times over. The team saw it almost immediately. Their solution for toasters and TV remotes was actually the perfect solution for the internet, and the entire brilliant idea was built around one single, incredibly elegant concept. Say hello to the Java Virtual Machine, or the JVM. The absolute genius of the JVM is that it's a piece of software that pretends to be a computer. So instead of compiling your Java code for every different kind of real computer, you just compile it once into a universal language called bytecode. Then, the JVM acts like a universal translator, reading that bytecode and making it run on whatever machine it's installed on. I mean, this was a paradigm shift. For the first time, your software didn't have to be tied to your hardware. So this three-step process is the secret sauce. 1. You write your code once. 2. You compile it once into that universal bytecode. And 3. The JVM can execute it on any device. Not only did this solve the run anywhere problem, but it also solved a huge security problem. Because the JVM was in total control, it could create a sandbox for the program, basically a safe play area, preventing it from doing anything nasty to your computer. But launching Java in 1995, that was just the starting line. The language didn't stand still for a second. It immediately entered this period of explosive growth and nonstop evolution to keep up with what the world needed. And the pace was just relentless. I mean, look at this timeline. We're not talking about little bug fixes. Major releases like Java 1.1 and the whole second generation of Java 2 added massive new libraries and totally refined the core features. The language was constantly adapting. But then we get to 2004 and J2SE5, wow. This one was a true revolution. It wasn't just an update, it brought in so many new features that it fundamentally changed how people wrote Java. Take generics, for example. It let developers write way more flexible and safer code that could work with different types of data without causing errors. These weren't just tweaks, they changed the whole personality of the language. Then fast forward to 2014, and another huge shift happens with Java 8. It introduced something called Lambda expressions. Just think of them as these little anonymous functions that you can pass around like data. This was a really big deal because it brought ideas from a completely different style of programming, functional programming, right into the Java world, and it just completely changed how developers could solve problems. So, after all these decades of change and innovation, what's the big picture? Why does this story still matter so much? Let's talk about Java's enduring legacy. From day one, the language was built on this core set of principles. The creators actually called them buzzwords. They were laser-focused on making a language that was simple enough for pros to master, secure by its very nature, and robust enough to not break in the wild environment of the web, all while being totally neutral to the computer it ran on and still offering high performance. And this philosophy worked. It works so well that Java basically became the blueprint for the next generation of languages. Its syntax, its object model, its whole look and feel were so effective that they directly inspired the design of other major languages, most famously Microsoft's C#. But really, if you want to boil it all down, Java's entire legacy can be captured in this one, single, incredibly ambitious phrase from its designers. It was never just about running on any machine today. It was about creating code that could last, code that could endure through decades of new hardware and new operating systems. And that really brings us full circle, doesn't it? The story of programming has always been a story of evolution. Each revolutionary language came along to solve a fundamental problem that the last one couldn't handle, from chaos to complexity to portability. Which leaves us with a really fascinating question to think about. What's the next great unsolved problem? And what will the language built to conquer it look like?